It's not entirely clear where we got cut off on the last attempt, but if c is the speed of light in a vacuum and v is the speed of light in a medium, then c over n1 equals v, or c over n equals v in any case, and we call n the index of refraction. The index of refraction is what we divide the speed of light in a vacuum by to get the speed of light in a given medium, and n1 then, or n, is a property of that medium, so that if we have medium 1, we say c over n1 equals v1. Similarly, c over n2 equals v2. Again, here, if we're coming from air into water, the index of refraction in air is very close to 1, so that the speed of light in air is essentially the same as the speed of light in a vacuum, whereas n2 is about 1.33, about 1 1/3, which means that the speed of light in this medium is about 3/4 of what it is in a vacuum. Okay, speed of light in water is about 1 over 1.33, which would be about 3/4 the speed of light in a vacuum. Now, applying Snell's law to this situation, it says that the sine of theta I over the sine of theta r is v1 over v2, which would be c over n1 divided by c over n2. The c's divide out, and we end up with n2 over n1. That is, the velocity, as we see from either of these relationships, is inversely proportional to the index of refraction. So if we have the proportionality of velocities, we have the inverse proportionality of the indices of refraction. For the angles that we observed for the system, kind of averaging the 28.3 and 25.5 degree angles to say that the angle of refraction as we go into the water is about 27 degrees, splitting the difference between the two values that we got. And if theta incident, the angle of the incident beam, is 39 degrees, and that's a little suspect because of the way we drew our perpendiculars. They probably aren't all that precise. In any case, if we accept these values, then the ratio n2 over n1 is 1.39, and we get that simply by putting theta I and theta r in here. We take the sine of 39 degrees divided by the sine of 27 degrees, and we get 1.39, and that's the ratio of our indices of refraction. Tells us that the velocity of light in the second medium is v1 over 1.39. Now, again, the accepted value should be about 1.33, so we really didn't do too badly. Now, when you do this experiment yourself, you might get more accurate results, better results. But this one isn't too bad, considering that we did it with fairly crude instruments.